Lesson 77, we get into finding surface areas and volumes of cones. So the main topic for today is going to be talking about cones. Obviously a cone, I'm sure you all are well aware of. Our base is going to be the shape of a circle, and then from that circle we have our sides that go up to the apex. For the first formula, we're going to talk about the lateral surface area, finding that particular cone. How do we find it? We start by taking the lateral surface area is going to be equal to pi r L. R is going to still stand for a radius. And L, as we've talked about before, is going to stand for our slant height. So to find the lateral surface area of the cone, we simply need to take pi times the radius times the slant height. Two variables and our one constant pi. Therefore, for example number 1, to calculate the lateral surface area of a cone with a slant height of 7 and a radius of 3, we simply start with our formula. Pi times radius times the slant height, where our radius is 3. Slant height is 7, and let's go ahead and leave our answers in terms of pi. Therefore, 21 pi units squared. And again, this is finding the lateral surface area of a cone given the slant height and the radius. Next, we move on to the surface area of a cone. Last formula was the lateral surface area. Now we're going to go ahead and find the lateral surface area again, but now we're going to add the area of the base to it. So the formula goes as follows. The surface area of the cone is equal to the lateral surface area, which is our capital L, plus the area of the base, which is always our capital B. We can go ahead and identify these variables off to the side. I'm going to go ahead and label it LSA for lateral surface area. Capital B is going to be the area of our base. So again, the surface area of a cone is going to be equal to the lateral surface area plus the base. Example number 2, we're going to go ahead and calculate the surface area of the cone with the slant height of 5 and the base radius of 4. First thing we want to find, let's go ahead and find that lateral surface area. So let's go ahead and find capital L. Capital L, as you recall from the last example, was pi times radius times the slant height. Radius for this particular problem is 4. Slant height for this problem is 5. And let's again go ahead and leave this in terms of pi. Capital L now is going to be equal to 20 pi. Let's box this and save it. And Next, we move on to finding the area of the base. So let's go ahead and find big B. To find big B, recall that the area of the base is going to be a circle. So if we recall our formula for a circle, pi times radius squared. Radius is our only variable, and notice that the radius is 4. So when we plug 4 in for r, and we square it, we get 16 pi. Let's go ahead and box this as well. Lastly, we have big L and we have capital B. So now we can go back and use our formula. We take the lateral surface area plus the area of the base. So big L plus big B. We substitute 20 pi in for L, because that's what we found there. We substitute our 16 pi in for big B. And just like collecting like terms, we can go ahead and collect like radicals. 20 plus 16 will get us 36 pi. And just like with the lateral surface area as always is going to be units squared. Third and final formula from lesson. We're going to take a look at the volume of a cone. How do we find the volume of the cone? We are simply going to take 1/3 times big B times height, where big B again is the area of the base and height is going to be the height. I'm not going to write that out because I think at this point hopefully we know what the representation of big B and H is. Again, notice that if we were to find the volume of a prism, our formula for a prism is going to be big B times height. So in relation to the cone, we can see that, hey, the cone is actually just going to be 1/3 of the size of the actual prism. Or in this case, if we're talking about a cone, the prism would actually be a cylinder. So a cone with the same area of the base and height is actually going to be 1/3 of the size of the cylinder. With that in mind, let's go ahead and move on to example 3. What is the volume of a right cone with a radius of 3 and a height of 5? Everything's pretty straightforward. Again, the first thing we need to find is big B. That's the first variable in our formula. We don't know it off the top, so we got to go ahead and solve for it. Big B area again is the base. Shape the circle, so we go pi times radius squared. Radius in this case is going to be 3. Therefore, big B is going to be 9 pi. Box it. Now, with that in mind, formula 1/3 times big B times height. Therefore, if we plug in our values, 1/3 times the area of the base, which is 9 pi, times our regular height, which is 5. 1/3 of 9 is going to be 3, and 3 times 5 will get us 15. Therefore, 15 pi units cubed, since we're finding our volume. For a little practice, it's not going to take too long. I want you to go ahead and take a look at page 508, and we're looking at the lesson practice, problems A, B, and D. For A, you're finding the lateral area of the cone, B, you're finding the total surface area, and D, you're finding the volume of that particular traffic cone. Good luck, and we will see you back next week.